This week, we're going to look briefly at metallurgy, ancient people working with metals, and we're also going to related topic to this is archaeometry, which is using scientific techniques to answer archaeological questions. We'll also begin to look at bioarchaeology and human osteology and bioarchaeology. And this is using human skeletal remains to answer anthropological and archaeological questions. And next week, we will look at mortuary analysis, which will, I think, be useful in answering questions also about your cemetery project. Okay, so let's start off with metallurgy. The earliest use of metals dates to around 9,000 years ago, 8,000 years ago. And the beginnings of working with metals didn't involve fire or melting the metals down. It was cold hammering. And this actually also occurred in native North America as well, as we're going to see. The next big step, though, was obviously extracting metals from ore. Ore is the rock in the geologic layers that not only has metals but also has these other minerals. But you can't work it. It's not a, let's say, solid piece of copper or iron, and you need to actually extract the metal from the rock. This is known as smelting, as we're going to see. How did ancient people then take these metals and mix them together in different combinations to form alloys or other kinds of grades of metals? Okay, metallurgy developed around the world at different times independently. So here's a ancient Chinese bronze. Here's an ancient gold piece from South America, from the Moche civilization. So inventive humans all over the world were able to create a technology where they could melt metals down and also do some other things with metals as well, as we're going to see. South America, you can see here's a silver llama. This is the kind of mold that would have been used to make one of those bronzes that you see from ancient China from about 1800, 1500 BC. In North America, Native Americans were able to access copper from the Lake Superior area. Right? So we're talking about the copper deposits that are in the UP and near Lake Superior. And these are pretty pure nuggets of copper. That's kind of rare. You don't always get that. But because they were pure nuggets of copper, ancient Native North Americans could cold hammer these pieces and make things like you see here, these decorative pieces. These are from a site called Spiro Mounds. Very important, I believe, Hopewell or Mississippian site. Okay, then in the Middle East, around 4000 BC, so we're talking about 6,000 years ago, people became more skilled with using pyrotechnology or fire, and they were able to take ore that had a mixture of copper and other minerals. Using high temperatures, they were then able to extract the copper and pour the copper into molds to create things like you can see here. Now, this is before the Bronze Age, and not many people know that there was a Copper Age right before the Bronze Age called the Chalcolithic. All right, so this is the beginnings of metallurgy. The process by which you take ore, heat it up, and extract the metal is called smelting. Copper melts at about 1,083 degrees Celsius. So in order to get those high temperatures, you can't just use a fire, an everyday fire like you'd see in a fire pit. You actually have to have people blowing air into it, right? Essentially adding oxygen to the fire to get the temperature really high up. And you're able to reach temperatures of over 1,000 degrees using a method like you can see here from an Egyptian tomb. People blowing on these tier pipes to create those high temperatures. Now what happens is that the impurities float up, and this is called slag. There's usually a hole in the furnace, and the slag kind of empties out, leaving a very pure form of the metal, copper or iron or what have you. Then what people would be able to do is then, once it was smelted, they would then take that copper ingot and then they would heat it up again into a liquid form, and they would pour it into molds in order to make axes or chisels or things like that. They may have hammered out sheets of bronze to make something like a helmet, but in general, copper and bronze were both cast into molds. That's how those objects were made. Here you can see a mold here, and the chisel that would have been this copper chisel that would have been gotten from that mold. Once people start to work with copper, they realize that copper is a very soft metal. They tried to harden the copper using different techniques. One of the techniques they used was adding arsenic to it, until they discovered that one of the best ways to harden copper was to add tin. And this is the first bronze. The benefits of bronze over copper are, one, it's harder. It makes better weapons, tools, and basically everything else. And also it will melt at a lower temperature. So once you have a bronze ingot, it requires less fuel and less heat to melt it up, to cast it. Right? So this is bronze. Now, as people started to experiment with other metals, they developed silver metallurgy, gold metallurgy. Eventually they started to work with iron. Iron required higher temperatures, but also iron requires different techniques in order to produce items from it. So iron was beginning to be used in the Middle East around 1200 BC, but it took a while for the technology to be really firmly in place before iron replaced bronze. So not surprisingly, like we've talked about with other technologies, you have overlap with the use of bronze and the use of iron. You also have overlap with the use of stone and the use of bronze. So iron, you have to get higher temperatures. You smelt. You take the ore, you get high temperatures in the furnace, and what you end up with is not a solid ingot, but you end up with kind of a spongy mass of iron and slag, which is called a bloom. You can see one of these kind of spongy iron blooms right here. What you then have to do is you have to take that bloom and start pounding it down and pounding out the slag that remains, if there is slag in it. Sometimes, as you're going to see with the video I want you to watch about Viking metallurgy, with some steel called crucible steel, they were able to actually get most of the slag out. Once you pound it down into an iron bar, what you would have is wrought iron. Now, wrought iron is great for use in chains, so even in the 19th century, early 20th century, wrought iron would be used for chains, for anchors and things like that, because it is pretty resistant to weathering compared to other kinds of iron. Problem is it's very, very soft. It has a very low carbon content. So it's malleable, it's soft, so it will not make very good weapons. If you make a sword out of wrought iron, it will bend. So people had to then add, take those iron bars and add some carbon to it to harden it. Now, if you had a bar that came from a bloom, you would not want to cast it in a mold to make your tool, because cast iron is very brittle. If you've ever been to a blacksmith shop before, you know that the way to turn a piece of iron into a weapon, a tool, a horseshoe, or whatnot is to do something called forging. Now, in forging, you're heating up the metal and you're pounding it on an anvil into the shape that you want. Now, you'll notice if you ever go to a blacksmith shop in some of these historic villages like Greenfield Village or some of the other ones, there's Charlton Park in Hastings, Michigan, most blacksmith shops are dark inside. You don't want to do this out in the bright sunlight because the color of the metal gives you an indication as to the temperature. You know, a white hot, yellow hot, red hot, you can tell if you're at the a precise temperature you need to be based on the color. And you won't see that color if you're out in the bright sunlight. So this is called forging, different from smelting. Now, eventually people developed steel. This is actually an alloy, combination of carbon and iron to produce something new, a harder substance called steel. There's different kinds of steel. There's mild steel, there's low carbon steel, which is more flexible. High carbon steel is much harder and it will hold a really good edge. Problem is it rusts quickly and it's brittle. So if you have like a high carbon knife, you'll notice that it holds a really good edge, but the thing rusts pretty quickly. It's not stainless steel, that's for sure. And also, if you took that knife and you tried to pry something open, you might snap the blade in two. Stainless steel is a little bit like low carbon steel. That has actually chromium in it to resist rust. But again, if you have a stainless steel knife and you sharpen it, you'll find out that it's not as sharp as a high carbon steel knife. High carbon steel makes the best edge. It holds the best edge. Now, in ancient times, actually in the Middle Ages, people figured out ways to combine the benefits of low carbon and high carbon steel. In Damascus steel, they would mix low carbon, high carbon steel together, and they would, in the forge, they would take a piece of high carbon and low carbon steel, and they would heat it up and fold it and weld it together, and then heat it up, fold it, and weld it together, then keep on folding it almost like a piece of clay. And at the end, if they used a little bit of acid, the patterns of the high carbon and low carbon steel would show up in this kind of very beautiful pattern. Japanese, to make their samurai swords, they would have a core of low carbon steel for flexibility as kind of the backbone of the sword, and high carbon steel holding the edge. So that was their technique of trying to have the flexibility of low carbon steel but the ability to hold an edge of the high carbon steel. Okay, now a good introduction to archaeometry, using scientific techniques to understand the archaeological question, is a video that I edited down to about 20 minutes about a particular kind of Viking sword that has been found called the Ulfberht sword. And it shows you a little bit about the technology and metallurgy, and it's a pretty interesting video, and I have a few questions for you just to answer about it.